Okay, now we're going to be looking at second order differential equation with particular solutions. So if we compare this to what we had in part 4 of this video series, in the previous video we see that our differential equation was equals to 0, but in this case it's equals to a function f of x. So now to get the general solution of this our differential equation, it will depend on the particular solution y particular and the complementary solution. So we have already seen how to look for the complementary solution, so we're not going to waste time in maybe showing the steps here. For those who um for those who did not watch the video, I'm going to put a link of the video above here so that you can watch. And now we're going to focus on the particular solution to get the general solution basically. So we could say this the general solution of a differential equation. So generally the particular solution will depend on three cases. The first case, when if we're talking of y particular, if we're talking of a polynomial, we know that for a polynomial it can either be a constant, a linear function, a quadratic, a cubic, and so on. So it goes on like that. So in that case, if we have a constant, therefore our particular solution will simply be a constant a or a constant c. Now if we have our function to be an exponential function, let's say e to the power nx, right, then our particular solution will simply be equals to a e to the power nx, and so on. If we have a trigonometric function, let's say our is a trig function, is a trigonometric function, then our particular solution will simply be y particular will simply be equals to a cos um, nx plus b sine nx. So depending on the function, so if we have, so examples are going to explain all of this. Examples are going to make this to look way more easier, or way easier than this. Now if we look at our first example, so now this is our first example, and we saw that to get our complementary solution, it will simply be n squared plus 3n minus 4 equal to 0. So we see that our complementary solution y complementary will simply be a e to the power minus 4x plus b e to the power x. Now the particular solution, in this case we have 8. 8 is a polynomial and it's a constant, so we're simply going to have our polynomial c. If in case we had maybe let's say 8x, therefore we're going to have our y particular will be ax plus b. So depending on what function we have here, we'll know the particular solution we're going to describe. So looking at the first derivative, we have dy dx to give us a, since it's a constant, the derivative of a constant is 0, and the second derivative of this will still be 0. So we see clearly here that if we put this in our original equation up here, then we're going to have 0 plus 3 0 plus 3 times 0 minus 4 into our y here. From here our y is c, therefore we're going to have 4c to give us 8. So clearly we see that our c is minus 2. So therefore we have our particular solution y particular will simply be minus 2. So to get our general solution, so our general solution will be y general equals to y particular plus y complementary, or better still y complementary plus y particular. So our general solution will simply be equals to a e to the power, we had minus 4x plus b e to the power x now minus 2. So that is our general solution. Now from this general solution, we can be given conditions to look for the value of a and b. So the conditions might be x equal to 0, dy dx equals to 2, and y equal to 1. So basically we're going to have simultaneous equations, and we solve the simultaneous equation for the value of a and b. So moving on to the next question. Now moving on to this question, we see that our characteristic equation will be n squared, or sorry, our characteristic equation will be n squared plus 3n minus 4. We already saw that this gives us our complementary solution to be a e to the minus 4x plus b e to the x. So what we're interested in is the particular solution. So in this case we have a quadratic. So our y particular will simply be equals to ax squared plus bx plus c. So that is our particular solution. Now if we look at this is like the general formula of a quadratic equation, or the general formula of a quadratic equation. So if in case there was no 3, then still we are going to have this. If we had just x squared, then still the particular solutions will be ax squared plus bx plus c. So if we had maybe, let's say, 3x cubed, then we are going to have our particular solution to be ax cubed plus bx squared plus cx plus d, and so on. Now we are going to look for the first derivative of our function. So we are going to have, when we differentiate ax squared, we are going to have 2ax. Now plus differentiating bx, we are going to have b. Now looking for the second derivative of our function, then we are going to have 2a. So we are simply going to substitute this and this and y in our equation. So if we name this equation 1, equation 3, equation 3, if we substitute it in our original equation above here, then we are going to have our second derivative is 2a. So we are going to have 2a here now plus 3 into our first derivative is 2a x plus b, and minus 4 into our y is ax squared plus bx plus c. So looking at this, equal to 3 plus 8x squared. So we're going to open our bracket and we simplify. So this will be 2a plus 6ax plus 3b. Now here we're going to have minus 4ax squared minus 4bx minus 4c equal to, let's say, 8x squared plus 0x plus 3. So if we rearrange this function, we're going to have 4a x squared. Now all the factors, all the terms in term, all the variables in terms of x, all the terms in terms of x, we're going to have 6a here, so this is gone, minus 4b here, so this is also gone, so this is all x. Now the constant terms will be plus 2a plus 3b, so that is also gone, minus 4c equals to 8x squared plus 0x plus 3. So if we equate our coefficients, then we see that minus 4a will simply be equal to 8. So this implies that our a is minus 2, and 6a minus 4b will simply be equal to 0, So we have our 6a to be equals to 4b, but we know our a is minus 2, therefore we have minus 12 here should be equals to 4b. So this implies that our b will be equals to minus 3. So we keep that aside. Now in the third case, we have 2a plus b plus 3b equals to 3. So we have already had the value of a, b and c. AB, so we want the value of c. So basically here we have plus, basically this will be minus 4c. Okay, minus 4c, this will be equal to 3. So we simply input our values. So we're going to have minus 4 there, and minus 9 minus 4c equal to 3. So basically this will be minus 13. So negative 4c to be equals to 3 plus 13. So this will give us 16. So minus 4c to be equals to 16. And we know 16 is 4 times 4. Therefore, c should be equal to minus 4. C will be minus 4. So we have our a, b, and c. Therefore, our particular solution will simply be equals to our a is minus 2x squared plus b minus 3x plus c minus 4. So that's our particular solution. Therefore, our general solution, y general, will be equals to y complementary. We saw that our complementary solution was a e to the minus 4x plus b e to the x. Now, our particular solution should be minus 2x squared minus 3x minus 4. So that's our general solution. Now this is a special case of the general solution, because there is going to be a cancellation at one moment. So to get our complementary solution, our y complementary will simply be equals to n squared minus n minus 2 equal to 0. So basically we see here that okay, now looking at our complementary solution, y complementary should be n squared minus n minus 2 equal to 0. So we have our factors to be minus 2 and 1, and n1 will simply be 2, and n2 will simply be minus 1. Therefore, our complementary solution will be a e to the 2x plus b e to the minus x. Now if we look at our a e to the 2x, we compare it with what our particular solution, which is exponential form, was given to us. We see here that this e to the 2x is the same as e to the 2x. Therefore, generally or normally, our particular solution, y particular, was supposed to be equals to a e to the 2x. But since our complementary solution is part of the particular solution, this is not possible. Therefore, our particular solution in this case will simply be ax e to the 2x. Now, if we do this and we notice that there's still a cancellation, what we simply need to do is we take our y particular to be ax squared e to the 2x. We do that until there will be no cancellation actually. So we're going to go ahead to look for the first derivative of our function. Now, looking at the first derivative of this function dy dx will simply be equals to this is a product and a is a constant. So what we can do is we just factor out our a as a constant, and if we keep x constant and we differentiate this, we're going to have 2. So there is a 2 there, e to the 2x. Now plus, if we keep now our e to the 2x constant, we differentiate x, we're going to have e to the 2x. Now looking at our, so this can be written as 2ax e to the power 2x plus e to the 2x plus a e to the 2x plus a e to the 2x plus a e to the 2x. Now looking at the second derivative of this function, the second derivative of this function, which will be d squared y all over dx squared, all over dx squared. So here we're going to have, we see here that 2ax e to the 2x is exactly our y particular up here, just with a multiplicative factor of 2. So what we might do here is we factor out 2 and we copy the same function. So we're going to copy the same function because the derivative of this one is going to give us all of these. Therefore we're going to have 2ax e to the power 2x plus a e to the power 2x. Now we are done with differentiating this, so we are going to move ahead with this one plus. So basically that will be 2a e to the power 2x. So that's our second derivative. So what we need to do now is just to take the second derivative and the first derivative and y and put in this our equation here to get our values, our corresponding values. So the second derivative is I'm just simply going to simplify it. So we have 4a x e to the power 2x plus 2a e to the power 2x. Now plus, right, plus 2a e to the power 2x. Now our first derivative minus first derivative, so minus all of this. So minus all of this, it means that we're going to have minus we are at this level, so minus 2a 2ax e to the power 2x minus a e to the power 2x. So finally minus 2y minus 2, and our y here was ax e to the 2x, so it's ax e to the 2x. Now this was equals to, from our general equation, it was 3e to the 2x, so this will be 3 e to the power 2x. So we see here that e to the power 2x is common, so e to the 2x will cancel with e to the 2x, cancel e to the 2x all through, so that is going to reduce our work. And now we're going to have 4a here, 4a plus 2a, we're going to have 6a plus 2a, that is 8a, so minus a here, so this is going to give us 7a. So this will give us 7a. Now we are done with that. Nope, not 7a. So let's just factor out our function. So we know that this is in terms of x, so I'm just going to underline all the values in terms of all the terms in x. We're going to have, so we are going to have here 4a minus 2a minus 2a, so all of that will give us x. Now plus 2a, all the terms in x plus 2a, all the constant terms, plus 2a minus a, so this will simply give us, all of this will be equal to 3. So we see here that this is going to cancel out, and from here we could see that even, so this could just cancel out here, so we'll be left with 3a. So 3a should be equal to 3. This implies that our a should be 1. Therefore our particular solution will simply be 1 So 1x, which is x e to the 2x. So it will be x e to the 2x. So our general solution will finally be y general will finally be equals to our y particular or y complementary a e to the 2x, a e to the 2x, a e to the 2x plus b e to the minus x plus our particular solution plus x e to the 2x. So that is our general solution. Now we're going to look at the last example. Okay, now onto this question. It says d squared y all over dx squared plus 16y equals to 2 cos 2x. So we're going to look for the characteristic equation, and the characteristic equation is simply n squared plus 16 equal to 0. So we have n squared will be equal to minus 16, implies that n squared will be equal to minus 4 squared. So it means our n will be equals to plus or minus 2i, 4i, basically 4i. Now we can write this as n to be equals to 0 plus or minus 4i, 4i. So see here clearly that our n1 is 0 and our n2 is 4. Since we have complex root, therefore our complementary solution y complementary will simply be equals to e to the power n1 0 into a cos n2x, which will be 4x plus b sine 4x. So that's our complementary solution. So we'll keep that aside, and to get our general solution we need to look at the particular um, solution. So for our particular solution, we see that our particular integral, when we look at this, our particular integral is part of our complementary solution. Therefore there's going to be a problem with this alignment or with this similarity. So instead of just saying that our y particular is equals to a cos 4x plus b sine 4x, if we take this to be our particular solution, therefore it's going to cancel at the end. So basically we're not going to take this as our particular solution, but instead we're going to look at y particular this time around to be equals to ax cos 4x plus bx sine 4x. So that's our particular solution, because the particular solution is part of the complementary solution. So that way our particular solution will normally not be this one. So now we'll go ahead to look for the first derivative, and from the first derivative we look for a second derivative, and we substitute here to get the necessary variables. Now looking for the first derivative, our dy all over dx, this will basically be, now we're going to keep x constant, we're going to keep ax, a cos 4x and differentiate x. So basically we'll have a cos 4x. When we differentiate x, we're going to have 1. So plus, now we're going to keep ax constant and differentiate cos x. So instead of having plus, we're going to have minus. So we're going to have, since the derivative of sine of cos is negative sine, and differentiating 4x, we're going to have 4. So it will be minus 4. Since we're keeping ax constant, we have ax, and the derivative of cos is minus sign, that is the minus 4x. So we are done with with this derivative. We are done with this derivative here. Now moving on to the second derivative. We're going to keep b sine 4x constant, so plus b sine 4x constant, and now when we differentiate x, we're simply going to have our 1, and we'll multiply here is going to give us this, so plus. Now the derivative of sine is cos, so we are free to write our positive, and when we differentiate 4x, we're going to get 4, so it will be 4bx, and the derivative of sine is cos, so cos 4x. So this is our first derivative. Now we're going to use our first derivative to get our second derivative. Now to get our second derivative, d squared y all over the x squared will simply be equals to, so we're going to look for the derivative of this. So now looking at this, we'll look at them individually. So this is 1, 2, 3 and 4. Now looking at the first one, the derivative of, when we differentiate cos, we have negative sign, and since it's 4x, so we are going to have minus 4 sine 4x. So we are done with 1. Now going on to this, we're going to have minus, so when we look at this, we can factor out our negative 4. In fact, negative 4a. We can factor out negative 4a, and then we will be dealing with just this, so that we're going to get keeping x constant, or keeping sine 4x constant and differentiating x, we're going to simply get our 1. So we are going to have sine 4x now plus, and now keeping x constant and differentiating sine 4x, so it will be 4x cos 4x. So we are also done with this, and moving on to the third term. So the derivative of this will simply be plus 4b cos 4x. And now finally here, the derivative of cos is minus sine, so since we are differentiating this and keeping the others constant, so it will be minus 16, normally 16, right? And normally here is 16, so here should be 16, so 16 bx sine 4x plus 4b cos 4x. So that's what we have in that case. So now coming back to this, okay, let's just say it's 4 there. It's 4 actually. Now simplifying this, we're going to have our d squared y all over the x squared to give us, so this will give us minus 4 sine 4x and minus 4a sine 4x minus 16 ax cos 4x plus 4b cos 4x minus 16bx sine 4x plus 4b cos 4x. Okay, we have this. So basically we are going to first of all simplify this before putting it in our equation up here. We have to simplify that before putting it above here. So now we have our terms in x and terms in y. So the best thing we could do here is, if we are to, okay, let's just assume that this is in the original equation above. Let's say it's in the original equation above. Oh my, this is in the original equation above. Now plus, when we look at this, we have plus 16y. So plus 16y. So plus 16, and our y is, we saw that our y is ax cos 4x, ax cos 4x, ax cos 4x, x plus 16 bx sine 4x equal to, so this is equals to 2 cos 4x. So this will be equals to 2 cos 4x, 2 cos 4x. So what we're going to do is we're going to compare now the coefficients. So we see that the terms containing x are supposed to be on the same side, and those containing y are supposed to be on the same side, or simply the terms containing cos x should be on one side, and the terms containing cos y or cos 4x should be on the other side. So basically we're going to be comparing our terms here, or we're going to be comparing coefficients. So we have to combine all the terms on the left hand side. We'll separate them into sine, and the terms all separate them into cos. So basically here we have to compare our coefficients, and to do that we simply need to separate all the terms containing cos 4x on one side, and separate all the terms containing sine 4x on the other side. So if we do that and compare with our right hand side, we're going to get that. So here let's just bring all the terms in x. So it will be negative 4. So I'm finished with this. This one is in x, so minus 4a. I'm finished with that. And this is in x, this is in cos x, and this is with cos x, so minus 16bx, minus 16bx, minus 16bx, and plus 16bx sine 4x, plus 16bx sine, right, 16bx. So all of this is in terms of sine 4x. Now, so we're done with all the terms in sine x. We're done with all the terms in sine x. We're now going to move forward to deal with the terms in cos x. So the first one should be minus 16ax. So we're done with that term. And the next one should be plus 4b. Plus 4b, we're done with that. And then the next one plus 4b. 4b, we're also done with that. And plus 16 plus 16ax, plus 16ax. We're finally done with that. All that cos 4x. So this will be equal to 2 cos 4x. 2 cos 4x. Now we just have to further simplify this because we see things cancelling out, and also here. Therefore, here we have minus 4 minus 4a, all that sine 4x will simply be plus 4b plus, so I'm kind of like a bit afraid here. Is it 4b? Let's look at it again. Is it 4 or 4b? So actually it's 4. So it's 4b equals 4 equals 4x, and 4b equals, well, it's 4. So this is going to give us 8. Therefore here is going to give us 8. So there it's going to give us 8b. 8b equals 4x. So this will be equal to 2 cos 4x. So we might want to write maybe plus 0 sine 4x, so that we see it clearly, or even, yeah, something like that. So that from here we say, comparing our terms, we see that negative 4 minus 4a should be equal to 0, and this implies that our a is minus 1. So that is the value of a, and comparing the terms with an 8b, 8b is equal to 2. So it's equal to 2. This implies that b is equal to 1/4, 1 on 4. So b is 1 on 4. So that's our b, that is the value of b. So we're going to go back to our particular solution and then simply substitute it. So our y particular will simply be equals to, it was ax, right? So when we look at our y particular, we saw that the particular solution was ax cos 4x. So a should be minus ax. So minus x cos 4x. Now plus bx, so plus 1/4 b, which is b, x sine 4x. So that our general solution, y general, will be equals to our particular solution, our y particular plus y complementary, so that our general solution should be, now our particular solution, we had it above here, we had our particular solution above here to be our complementary solution pattern to be a cos 4x plus b sine 4x, a cos 4x plus b sine 4x, a cos 4x plus b sine 4x. Now plus our complementary solution should be minus x cos 4x plus 1 all over 4x sine 4x. So that is what we have for that. So that's what we have. So generally, that's our general solution. So thank you guys for watching till the end, and if you haven't seen the part 1, 2, 3 and 4 of the video series, I'm going to put a link in the description box and also as a card above, so that you guys can get access to that. So I'll see you guys in the next video.